this is one of the options. We can talk about economies of speed, how we use speed as a tool to drive better behaviours in software development. Since we're all winging it here, more than happy for you to just throw up questions and interrupt me and we can discuss things. If there are avenues in this that you'd like to explore, let's just do that rather than be very formal about a presentation. So the idea of this really is thinking about, how do we start to make progress? I think that continuous delivery is an important idea. I'm one of the authors of the book that introduced the concepts to most people. And I think it's important because it drives us in the direction of some fundamental principles that are important to the engineering of excellent software. We can kind of point to organizations that are great at software delivery, and these days nearly all of the greats are practicing continuous delivery in one form or another. So this is, the pragmatic evidence is there for us to believe that there's something important here. If you come to any of my other talks, you're going to be seeing me talking about very similar related topics. But one of the things that's about continuous delivery is it's about working so our software is always in a releasable state. That's my preferred definition of what we mean when we describe continuous delivery. And if we're working so our software is always in a releasable state, the always bit matters as well as the releasable bit. So we want to try and find as often as we can whether our software is releasable. That means we've got to go fast. We've got to make progress in small steps so that we can observe what's going on in those steps and understand where we are and understand whether our software is releasable or not. In recent years, so when Jez and I wrote our book, when we were working on the projects that kind of pioneered some of these ideas, in parallel with other organizations doing similar things, we were just kind of winging it, really. We were just sort of working empirically. Basically, on the projects that we were working on, we were doing lots of stuff wrong, figuring out what we were doing wrong, and we were fixing it, bit by bit by bit. That's quite a good engineering discipline in its own right. If you think about the evolution of aeroplanes, they started off made out of wood and string and fabric and killed lots of people. In 2017, commercial aviation flew the equivalent of 2/3 of the population of the planet, and no person was killed in commercial aviation in that year. That's the first time that happened, but that only happens through a series of gradual improvements, in that case, over a century. So this idea of incrementalism is kind of important, and that's where we started from. But then this happened. The State of DevOps report was published, and the State of DevOps report did, at least to my knowledge, for the first time really, a genuine sociological analysis and exploration of software development as a practice. And they used valid, kind of peer-reviewed statistical techniques for the collection and analysis of the data. So this is the best. It's still sociology, it's not physics, so it's a little bit woolly, it's a little bit fuzzy. You can't have controlled experiments in sociology, really, to the same degree that you can in physics. But it says some important things. And the science that I'm describing was captured in this book, written by Nicole Fosgren, Gene Kim and Jez Humble, Accelerate, which I think is an important book for our industry because I think it helps to put our industry on a slightly more scientifically rational footing. We can kind of make decisions based on evidence rather than just crossing our fingers and hoping, or the latest fashion in what's the current best Java framework or whatever. There are better ways of making choices than that. One of the key ideas that this research was built on was measuring the performance of teams based on two ideas, throughput and stability. Throughput is measured by the lead time, how long it takes you to go from commit to something releasable, and the frequency with which you exercise that possibility and deploy it into production. That's a measure of the efficiency or the speed of our development process. Stability is based on two measures as well. It's on the change failure rate, what proportion of changes into production cause a failure of some kind, a bug, and when you find one, how long does it take you to fix it? That's a measure of the quality of the work that we produce. And this research found all sorts of really interesting things. There are orders of magnitude difference between high performers on these measures and low performers. High performers release 2,600 times more frequently than low performers. They have fewer defects. They fix them more quickly. All of these things. So they are not just producing software faster, they're producing better software faster. And there's some good reasons for this. So one of the findings, one of the really, I think, profound findings that this research discovered was that despite probably what most of us in this room were taught at some point, there's no trade-off between speed and quality. It's wrong. That argument to say you can either have it fast or you can have it good is just a lie. That's not true. If you want to do high-quality work, you must go quickly because you need to do that work in small steps, and so you must be progressing quickly. If you want to go quickly, you must do high-quality work because you can't afford to go back and do the rework, which is enormously costly when you look at it. On these measures, high performers spend 44% more of their time on creating new features than low performers. So what this is pointing to is that these are the kinds of numbers that we'd expect from a genuine engineering discipline. We'd expect that to be able to kind of turn up the volume on our capability to deliver great results. And this stuff does. The nature of the problem. This is something that I've taken from a book called The Art of Action by Stephen Bungay. But it's a lovely little model. If we think about doing something, we want to achieve some outcome of some kind, and then we're going to make a plan for how we're going to do that, and we're going to carry out the actions that we expect to do, and we hope then to get the outcome that we're looking for, and you get this little kind of loop around. But there's a problem here. There's a knowledge gap. There's a difference between what we'd like to know and what we really know. And that's a problem. That's always a gap. That's always there. And then there's another gap between the plans and the actions. That's the alignment gap, is that what you'd like people to do when you've made your plan and what they actually do. Because we're all human beings. We're all kind of fuzzy, clever processing units, and we do our own thing very often. We don't rigidly follow a plan. We're not computers. And then there's the effects gap, and that's, even if we did all the stuff right, there's the difference between what we hoped was going to happen when we did this thing and what actually happens. And these seem to be pretty fundamental. If you look at traditional responses to these kinds of problems, then it's usually something like, okay, we'll plan harder, we'll be more thorough in our analysis, we'll spend more months thinking hard about this problem, and we'll analyse more. We'll figure out what's going wrong, and we'll do more detailed requirements. That's bound to work. But it doesn't. We've been trying to do that I've been working in software professionally for about 40 years. We've been doing it all that time. Then there's the alignments gap. So what would we like people to do versus what they really do? And the traditional response for that is, okay, we'll micromanage people. We'll tell them exactly what it is that they must be doing. We'll up the level of process control, and that's definitely going to fix things. And we'll add more bureaucracy, because that's always a good thing, right? And of course, that doesn't work either. And then the effects gap. We do expectation management. We say, oh yeah, well, this is going to be really good. And we do, I laughed when I came across this, watermelon status reporting. If you haven't heard about that before, it's green on the outside and it's red in the middle. So we all know that it's going to shit, but we tell our bosses that everything's going to be fine. And then we increase project management rigor. That's how we solve that problem. And again, we've been doing that for a very long time, and that hasn't worked either. There's a much simpler solution. We can't eradicate those gaps. You can only work to reduce them. And the way that you work to reduce them is you shrink the cycle. You work in small steps. You work in smaller steps, and that speeds up the process. That reduces the risk inherent in each of those gaps. If we're not sure, what our plan should be, we can try something and see if it moves us closer to our goal or further from our goal. And if it moves us further from our goal, we change it. We change the plan. If people aren't doing what we want, we find ways of fixing that too. If we're not delivering the outcome into production correctly, we fix that too. By working, cycling around this much more quickly and much more efficiently, we address all of these problems. They don't go away. We can always still screw up. That's the privilege of the engineer. we are inevitably and destined to make mistakes. A good engineer responds to the mistakes that they make and fixes them, and doesn't make the same mistake again. So, another way of thinking about this, in thinking in terms of speed and the utility of speed, is an idea that I stole from a friend of mine, Gregor Hope, who's fantastic on talking about kind of enterprise architecture, enterprise IT. He's been very senior in Google at times. He was the head of IT for Allianz, the German insurance company, and he's very insightful about these kinds of things. And I was at a conference when Gregor described this model, which I really loved. So I'm just going to point this out to you. So a way of telling where you are in your organization is to think about how your business perceives the function of dealing with information technology. If the information technology function in your organization reports to the chief financial officer, then their primary focus is going to be on cost, because that's their job. And so the obvious strategy for them is to outsource IT and find a cheaper way of doing it somehow, and the only thing they're interested in is cost cutting. You don't get great IT this way. I'm using IT, it's a very old-fashioned way of describing what it is that we do, and I hate it, but it's just what we used in the presentation. The next is thinking about what the asset is in terms of the asset. If the IT function reports to the chief operations officer, then primarily that kind of person is interested in return on investment. So they're going to be looking to harmonize and rationalize the function and looking for economies of scale. How do we do this so that we can get the most bang for the buck in terms of what it is that we're doing? If you have something like a role like a chief digital officer, that starts to change the game, because that's starting to see that this is a function that's at the top level of the organization, reporting to the CEO, which gets us on to the next one. These two are substantially different. I would kind of classify the two on the left as kind of old world and the two on the right as kind of new world, pretty much for what we're talking about. If you're reporting to if IT is reporting to the CDO, then they're going to be focused on business value. They're going to insource IT because that's the unique value for the business. You can't imagine Google or Amazon outsourcing their IT on any significant scale. And they're going to be business case driven. The holy grail that modern organizations, effective organizations, seek is that IT reports directly to the CEO. They are partners in the business. Now, the driver is speed of innovation. IT is the business. Think of organizations like Tesla or SpaceX or Amazon or Google. IT is the business. There's no difference there, really. And now we're starting to talk about ideas of economies of speed. So how do we go really, really, really quickly so that we can close all of those gaps and learn really, really quickly? That's the nature of our game. That's what it is that we're all kind of employed to do. I would argue that these things are kind of profoundly important. Part of my job these days is to advise usually large organizations on how to adopt better engineering principles in their organization, primarily how to adopt continuous delivery in DevOps, SRE, those kinds of things. But the primary tool that I use is speed. If you are releasing software into production once every 6 months, I'm going to advise you to start releasing it into production once every 4 months. That's going to stress your organization, it's going to stress your processes, it's probably going to stress your technology, and in order to do that, you're going to have to fix a lot of things. And then when you fix that, I'm going to say, start releasing every 2 months. And it's going to stress them again. And you carry on doing that. And it's going to take you a long time. But you carry on doing that until you can release at least once every day. Or at least you're in a position to release once every day. I'm differentiating here between continuous delivery and continuous deployment. Continuous delivery is working so our software is always releasable, but business context means that you don't always have to release, or you may not always be able to release. But releasing sooner is good. So we want to optimize so that we can generate releasable software. It's the most definitive way that we as technologists can work. It gives us the clearest signal that what we're doing is building stuff right. And then we want to go into the market as quickly and as efficiently as we can, as frequently as we can, so we can get a signal back from our users to figure out whether we're building the right things as well, and learn from those. So I would say that these are kind of traditionally structured organizations, and these are what we might term, using the jargon of the day, sort of digitally disruptive organizations. This is where the real game is in terms of innovation, technical software innovation, driving change in business, which it is around the world, of course. You know, weirdly, us bunch of nerds are the actors that are changing the world. You know, that's what's going on at the moment in our society. But this is how we do it well. So how do we look to achieve these economies of speed? Sorry, it's ages since I did this presentation. So fundamentally, I'd argue that this is what all software organizations want. We want to be able to have an idea, we want to be able to get that idea out into the hands of our users, and we want to figure out whether it's a good idea or a bad idea as quickly and as efficiently as we can. So we want to establish that feedback loop so that we can learn really, really fast. And what this requires of us is great technical performance. We've got to be able to do things with high quality, and we've got to be able to do things quickly with high quality. So that demands of us skills that are going to allow us to do those kinds of things. But it also requires great cultural performance. We also need to have the right kind of mindset. We need to have the right kind of focus to be able to do a good job. We need a level of discipline, for want of a better term. It's an unpleasant term, particularly coming from an old man to a bunch of younger people, mostly. Except for you, sir, perhaps. But it's something that's important to be able to get right. Whoops. Okay. So we require some level of discipline. There was a famous paper published in 1986 by Fred Brooks, the author of The Mythical Man Month. It was called There's No Silver Bullet. And Fred's premise was there's no change in software or process, software technology or process, language, any of those things, that will give us a 10x improvement in productivity. And I think he's right. And I think if you look at the history of our industry, I think he's right. I wrote a book, I published a book recently, which is called Modern Software Engineering. But as part of the book, which didn't actually end up in the book, I did a fun exercise in that I wrote a simple CRUD application in a modern, well-respected, widely used web framework. And I did it in the technologies of 1996 using just Java, JavaScript, HTML, and CSS. And the 1996 version was about a quarter of the code of the 2022 version. Sure, the new stuff did some things better. It did browser independence better than the old technology did. But that was about the only gain that I got from using it. It was an interesting thing. So this idea of there being no real advance in our thinking is kind of disturbing somewhat in terms of the way that we think about our industry. But I think that one of the things that Fred missed is that there are what I'd call mud bullets. we can use really bad bullets, and we're not very good as an industry of discarding the bad ideas. So my observation is that if you are world class, there's no 10x for you, but the vast majority of us are not. And there's way more than 10x for what average looks like in our industry, is my observation. If we use the best techniques and technologies and approaches and processes primarily, to be honest, that are available to us. So cultural performance really matters, sort of applying this in a slightly more disciplined way. And then there's organisational performance. Oops, that went too quick. You can imagine what it said. It said technical performance, cultural performance, organisational performance. Organisational performance is important because we've learned that dividing, if we want to build software at scale, it's no good having a massive team. We need small teams, and if we need small teams that are autonomous, that are free to make progress on their own without collaborating with other teams, that takes smart organisational structure and design and smart leadership to be able to free those teams to make progress quickly and efficiently. There's a fantastic book, which if you haven't read, I would recommend to everybody in the room, called Team Topologies by Matt Skelton and Manuel Pais, which describes this. It describes how you can you kind of start a software project by first designing the team structure that's going to be able to deliver the kind of software project that you think you want. And it describes the mechanisms. There are 4 types of teams and several different ways in which they can interact, but it's a narrow few. Great book, recommend it to you. This is a deployment pipeline. This is an idea at the heart of continuous delivery. This is one of the mechanisms that can give us a route to that great technical performance. The objective of a deployment pipeline is to automate the decision-making from commit to releasable outcome, fundamentally. At the conclusion of the deployment pipeline, there should be no more work to do before you're happy to release the change into production. That's what a deployment pipeline is. It's a mechanism to deliver that. And that will force us to, or help us and give us a platform with which we can drive this kind of cultural change. This kind of technical change. This is a quote from the Harvard Business Review. Agile innovation has revolutionized the software industry, blah, 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 blah. At this point, the greatest impediment is not the need for better methodologies, empirical evidence, or significant benefits, or proof that Agile can work outside of IT. It's the behavior of executives. This is a mindset change, and one of the things that we as a profession are doing is that we've been challenging traditional assumptions in organizations. If you look at my current, look at them organizations are, I'm afraid, both Elon Musk's, they're Tesla and SpaceX. I heard something recently which kind of surprised even me, who's a continuous delivery, test-driven development advocate. SpaceX are uploading software onto their rockets 40 minutes before a launch. These are rockets that carry people. They have that level of confidence in their engineering and their approach. That's what this can do. Tesla wanted to upgrade the maximum charge rate that the Model 3 car could take. It went from 200 kilowatts to 250 kilowatts. This was a physical change in the routing of some heavyweight cabling in the power distribution system in the car, which meant changing the production line. And they did it in software, and the software change was committed 3 hours later. It had run through a bunch of tests. They run test trunk-based development, test-driven development. 3 hours later, the production line was producing Tesla Model 3s with 250 kilowatt maximum charge rate. That's what this kind of engineering stance can give us. If people push against this, say, oh no, we've got to deliver faster, this is the fastest way to deliver change. So this quote is kind of true. The only reason that we're not doing a better job in many organizations is because people don't believe that we can, and we can. In terms of organizational performance, this is another little model how most organizations work. So you start off making a decision based on the organizational structure. This is taken from Jan Bosch. This is not my original work. But you start off with the organizational structure. The business then decides what it can do based on that organizational structure. We then come up with some kind of architecture or approach that we're going to deliver, define the process that will deliver it, and that's how we deliver change. That's dumb. That's a really stupid way around of doing it if you think about it, because what we really should be focused on is the outcome. So the business should be setting the goal. Then we figure out what that's going to take to deliver and come up with an architecture and a process to deliver us. Then we design the organization that can deliver that for us. So the organizational design is a tool. It's not a rigid constraint that should stop us being able to make progress. It's something that it should be fluid, and we should be able to change to optimize our approach. How is it that we get to move fast? So, if we're all moving in step, then we are proceeding at the rate of the slowest. If one of the people or the teams kind of can't make progress, it holds back everybody else. If there's a problem of some kind, that too kind of along the way, that's going to hold us back as well. All of us, if we're all coupled together. If we decouple the teams and allow them to make progress autonomously, independently, then we get whatever they can deliver as quickly as possible. That's the way that Amazon work. They've decoupled their whole organization, and therefore they can proceed without any real ties. And again, this is kind of software information theory style thinking now being applied to business structure and team organization and so on. Coupling is the biggest barrier to progress, and so we need to treat it seriously if we're going to manage it effectively. Oops, sorry. So the trade-off to reduce coupling is to discard consistency. And that's a scary thought, but that's kind of what it takes to be able to really break those bounds. We need to relax the constraints of consistency. There's another quote from Fred Brooks: you can't make a baby in a month with 9 women. There are some fixed periods that it takes to do some kinds of activities. Things are not infinitely parallelizable. We have to think about things in different ways. I'm conscious that I'm running out of time, and I kibbutz this anyway. I kind of jumped in on this anyway, so I don't want to waste too much of your time. This is just a lovely little study that I kind of like about team size. This is a metadata study of over 4,000 projects that looked at how long would it take each team to get to 100,000 lines of code. They divided the teams into 2 cohorts, teams of 5 people and fewer, and people of 20 people and more. What they found was that on average, it takes a team of people about 9 months to get to 100,000 lines of code. As you might expect, the teams of 20 people beat the teams of 5 people, but over a 9-month period, they beat them by a week on average. So the first thing that this study says is that a team of 5 people is almost, but not quite, 4 times as productive as a team of 20 people. Then they looked at the defect rates, and the defect rates for the team of 20 people were 5 times higher than for the teams of 5 people. So teams of 20 people write worse software slower. That's what the data says. I'm going to stop at this point because I don't want to take more of your time, and I want to give you some time to ask any questions.